Welcome. First of all, note this class in YouTube I am making public, but it is not for general public. It is meant only for those who are in the group or batch of Staad Pro. Actually, course is Design of Structures, RCC and Steel by Staad Pro, including all the basic concepts required and also details of the software and finally project. Course is running. This is class number 71. This class was taken yesterday, but due to technical problem, there was a tech problem. Class cannot be completed. Even a lot of complaints were there regarding the visibility. So, for that purpose, I am recording it now. So, others, those who are general public, if you understand well and good, use it. But if doubts are there, do not put the blame on me, because this class I told is meant only for my particular group. For them, doubts will not come. I am sure everything is told. So I am taking the class as if I am taking for the group. But others, those who got little knowledge, can understand. Okay. Last class, see class number 70, where I wrote here. I don't know where I wrote here. Previous class, I gave systematic procedure for finding design shear strength for cross section of beams, that is VD. Then today I started examples, then trouble came. Okay, now go through it. So I told the star is information for you. So examples for finding design shear strength for beam cross section, that is called VD. See, note in previous class, that is steel class 70, systematic procedure with complete explanation is given. Was given by past tense. Okay, was given. Oh, no problem. Now examples. Class warning. Warning for those who are in the group. When I start next design of beams, you require shear strength. That time I will not tell how to calculate. Why? Procedure systematically over. Examples also I am covering now. Therefore, remember everything what you have to do is complete details starting from here. See what all I told you, everything you write in a box. You already know what is a box means. People who are in the group, they know what is a box means. Write in a box. Later refer to it. Okay. Now question is here. Find design shear strength for beam cross sections given below. See, example 1, example 2, example 3. 3 questions are there. I will explain the questions here. First question. Rolled steel joist ISMB 500 at 86.9 kg per meter. This is actually over in the class, but that recording I am not sending. Second and third questions are welded I section. Okay, now first what you do, follow the procedure. See, briefly I will tell for others. To find design shear strength VD, first you have to decide whether web is susceptible to shear buckling or not. How to decide? See, if web is susceptible to shear buckling, it's a bad case, weak. Thin and deep web. If web is not susceptible to shear buckling, it is a good case, stronger. So, for that you find the value of first what? D by TW ratio, the ratio of D by TW. Remember this red color, D by TW is a bad number. Somebody may ask, what is bad? Those who are in the group, they know what is good and bad. Okay, now, before that, cross section is here. Breadth of flange, depth of section, thickness of flanges, radius at root R1, all told for you. What all this one told? From the IS code or handbook, you get these values. I noted down. Okay, now, first find D by TW ratio. What is D? It is the depth of web as defined by IS code. See, D is as defined by IS code for rolled steel joist. IS code told D is the weakest part of web, that is distance between the root fillet. See, the curvature is here. Here thickness is more, weakest is here. This is D. So that D equal to overall depth H. Overall depth H, where I wrote, okay, H minus thickness of flange plus R1 2 times. So 2 times of thickness of flange plus R1 or equal to overall depth is 500. I am not entered because ISMB 500 means depth is 500. You should know it. 500 minus 2 into 17.2 plus 70. This will come. I noted down the answer 431.6 to save the time. 431.6 millimeter. Now, therefore, calculate D by TW, or to make more clear, it's a bad number, so I will use red color. Therefore, D by TW ratio equal to 431.6. TW is 10.2. The number will come 42.31. 42.31. Okay. Now you have to compare this D by, see, for those who are in the group, everything is known. Actually, I used to tell in the class, I am wasting time. But at least some information so that everything is clear. You have to compare this D by TW with 67 epsilon as per IS code. See, refer to IS code. Find the value of 67 epsilon. Where epsilon, find what is 67 epsilon. Epsilon is root of 250 by Fy. Fy should be in Newton per mm square. 250 also has got unit of 250 Newton mm square. See, I told all questions I have given here Fy 250. I have not given anything. Okay, I will give here. See, in the question, take every question. Fy 250 MPa for all the questions. All three. To save the time. All three questions. So, root of 250 by 250 equal to 1. You know it. Therefore, your 67 epsilon equal to 67 into 1 equal to 67. Okay. Otherwise, calculate. Suppose Fy is more than 250, some decimal will come. Use it. Now compare. Therefore, your D by TW, which answer is how much? Ratio. Answer we got 42.31 is less than 67 epsilon. This number is equal to 67. Now, if D by TW, refer the procedure given. If D by TW is less than 67 epsilon or even equal, no problem. Therefore, right here, web is, see, D by TW is a bad number. If it is lesser means web is not too deep, not too thin. Medium. That shear buckling will not be there. Therefore, web is not susceptible. See, not susceptible to shear buckling. Shear buckling. That is, remember, you can write here, this is good case. Very good. Stronger web. Good. Then, as per IS code, page number you search. I have given last class, I told page numbers. Here all, I can't waste time searching for IS code page number all. IS code, design shear strength. Design shear strength of beam cross section. Beam cross section, that is called VD equal to Okay, first AV. Okay, first AV into FYW divided by root 3 divided by gamma MO. Okay, gamma MO you know it. Okay, now where AV is shear area. Shear area. Now see, shear area IS as per IS code. See now, for RSJ, for roll steel joist, here reasons all I told you. How is the shear stress distribution? This comes this. No, this is example. We cannot waste time. See, IS code decided. See, shear area is this portion. That is full area up top to bottom, but excluding flanges. So this is your AV. Therefore, your AV equal to, this is H. It is given H into TW equal to, H is 500, TW is 10.2. Answer will be 5100 mm square. Mm square. That's all. Substituting, right? Design shear strength. Once again, design shear strength for given beam cross section, that is called VD equal to, see there, where is the formula? Okay, write once again formula. Okay, AV into FYW by root 3 gamma MO. Now space problem is there. I slightly come this side. This question is over, so don't bother now. So this I will remove now. See, I will remove this one. I will continue here. To save the time. Continue. See right here. That is VD equal to AV. How much AV? 5100 into FYW is 250 divided by root 3 divided by 1.1. Why you should know in steel structures, when Fy is considered, gamma MO is 1.1. This will come in Newton. Answer will be 66 point. No, it is lesser. It is not 66.92. That's all. Only 66. There is some problem in the calculation. 1 minute. It is lesser. It is more. It is not 66. 1 minute. I put here. 5100 into 250 divided by root 3 divided by 1.1. Oh, see, it is not 66, it is 660. I got common sense. See, when I saw the number 66.92 there, decimal number mistake, I know, see, I got a common sense. It can't be that much, little okay, subject, so therefore equal to 669.20 10 to the power 3 Newton, that is 669.20 kilonewton is the design shear strength for the given RSJ. Okay, now question example 1 over. Now make a note. I will dictate here, you should write. Example 1 is for RSJ. Example 2 and example 3 are for welded section. For RSJ, see, there are two cases. One is web is not susceptible to shear buckling. Good. Stronger case. Or second one, web is susceptible to shear buckling. Weaker case. Bad. I considered RSJ and covered when web is not susceptible to shear buckling. Somebody will ask, sir, why are not covering other case for RSJ? No. All the roll steel joist available in India, D by TW will be very much less than 67 epsilon. So all the manufactured rolled steel joints used in India has d by tw within that limit. Above is not there. When it is not there, how I can solve? So that means when you solve a beam example later, my guarantee, if it is RSJ, you will always get the case of web not susceptible. Oh, now one more note. Suppose for the RSJ, you attach flange plates for extra strength. Then how to find? No. ISC. Now then, shear stress distribution will be something like this. Don't bother. These are all not required for you. This way. Or, see, even now, shear is taken entirely by web. So IS code told, no problem. You ignore the flanges. For shear, you take only this area. That is, even if flange plates are provided, this calculation remains same. You need not bother about the flange plate. You imagine it is not there. Okay, this is the case of finding design shear strength for RSJ. Now I will start second and third questions. Now I will start example 2. This already over. RSJ already over. Welded I section. See, this all you know it. 300 by 450 means what? This is 300. See, when they give 300 by 450, it is overall dimensions. 300 by 450. Flanges are 16 thick, 16, 16. Web is 12 mm thick. Okay, here. First, as usual, find d by tw. What is d? See, in RSJ, I should not tell. Be careful. See, from here to here, from the overall depth, subtract flange thickness, subtract R1 2 times. But in welded I section, see, there is no change of thickness. The depth of web is D. So IS code clearly told, you can make a note here. For welded I section, D stands for actual depth of web. So your D equal to, but be careful, it is not 450. See, 450 is total. So from 450, subtract 16, subtract 16. You get 418 millimeter. Okay, fine. D by TW. 418 by thickness of web is 12, 34.83. Calculate 67 epsilon, same as last time. Okay. So finally, D by TW came how much? 34.83 less than 67 epsilon. So once again, web is not susceptible to shear buckling. That is good case. Okay. Then same as last time, design shear strength VD equal to AVFYW by root 3 gamma MO. AV is the shear area. Now be careful. See, for RSJ, roll steel joist, be very careful. See, shear area is this one as per IS code. That is, from top to bottom, including flanges, outstands are ignored. This is AV. This is last time. That is for RSJ. And again, as per IS code, for welded I section, shear area is only the web area. Reason I told you last class. Here I can't discuss. This is examples, principles, etc. Everything clearly told in the last class. So shear area equal to, you can see here, this area is D. No, last time total depth into TW. Now only depth of web into TW. 418 into 12, 5016. Therefore, design shear strength AVFYW by root 3 gamma MO. Again, I will continue somewhere here now. This is not required. Okay, I will continue here. Continuing VD equal to substitute AV 5016 into FYW 250 divided by root 3 divided by 1.1 Newton. It will come, I wrote it down, 658.18 10 to the power 3 Newton, that is 658.18 kilonewton is the design shear strength. See, RSJ, you will always get web not susceptible. You will not get the case. So, RSJ with the plate, no problem. Welded eye section, you cannot tell. So, here we got not susceptible. Now, the last question number 3. See here, I will do one thing now. I want more space. For that one, what I will do is, this I will remove now. This all I will remove. Because I want more space for that one. More space, right. Question, example 3 start now. Example 3. Cross section given, right here. Cross section given for the beam. They told welded eye section. See, welded eye section. For this time, last time they told what? 300 by 450. Now they told welded eye section. They told flanges. See here. Only flanges. This is the flanges. This is the web. Scale is not maintained. This is flanges. Okay. Flange is how much? 250 by 20. This is 250. This thickness is 20. This also 20. 250. Then they told web 10 mm. 10 mm by 800. Oh, this time they are telling you depth of web. Be careful. This is 800. Last time, see, overall depth given, you subtracted the flange thickness to get depth of web. This time, depth of web given. So, if you want, you can find overall depth. Actually, not required. Unwanted. Okay, unwanted, right here. In case, but bending strength you require. See, 800 plus 40 more. 840 if required, but not required. Okay, now start. So this all you know it. Start as usual. First, what you will do? We'll start. Okay, this is remove. First, you require systematically. What you do? First, you require. You can put a heading for everything. Every time you start example, you write example for finding design shear strength. So first, get what value? Get D by TW ratio. For that, D you require. See here. Right. To save the time, I will do one thing now. More space required because more space is required. Okay. I will remove everything. This I will maintain. You go in the same order as I explained. See. First you require. Put a sketch here. I am removing everything now. See. Put a sketch. Right here. As per IS code, right here. For welded eye section, you should write. If you are interested, you should write. For welded eye section, the depth of web itself is D. So your D equal directly, see here, 800, no subtracting, 800 millimeter. TW equal to, already known there, 10 mm. Therefore, your ratio, D, see this sketch should come here, not there. See, it should come here. Okay, now, therefore, D by TW equal to 800 divided by 10, bad number 80. This is a bad number, no unit. Okay. Now find 67 epsilon. I told Fy is same, it will come 67, right? Therefore, D by TW, which is the bad number, this is meant for those who are my students, is more than, red color, see, danger, more than what? 67 epsilon. That is equal to 67. Therefore, be careful. Web is what? Therefore, web is susceptible, danger, susceptible to shear buckling. Right? Very bad. Very bad. That means you can write a note here. The strength of the web in shear for this case will be lesser than that web which is not susceptible. See, what strength you get here will be less than the strength if the web is not susceptible. That all comment lastly I will give. Okay, now correctly right here. Now to find shear strength. See, start. Remember now, as I proceed further, okay, 1 minute now, I will start somewhere here. This I will remove this sketch now. See, this sketch I will remove. Shear area I will do now only. See, okay, little later I will put. This sketch I will remove. I will start fresh now. Fresh I will start. As usual, to save the time, I will write all the calculation. Then I will explain. Why? Because procedure already given. So, important is application. I will write everything and start. Now, example 3 continued. I removed everything. See, just now we concluded that web is susceptible to shear buckling. That is bad case. Be very careful. See, if web is not susceptible to shear buckling, one line answer. AVFYW by root 3 gamma MO. Means the allowed stress is Fy by W by gamma root 3. Gamma MO is here also. See, even gamma MO is here also. So allowed stress in shear is Fyw by root 3. Reason I told. But now our web is susceptible to shear buckling. Bad. You can make a small note. That means the shear strength of web will be lesser than what it would have been if it is not susceptible to shear buckling. So, when IS code, when web is susceptible to shear buckling, that is when D by TW is more than 67 epsilon, design shear strength of cross section VD equal to, see, AV, 1 minute now, see, no, I don't want to waste time. Earlier formula is what? AV into Fyw by gamma MO by what? Root 3. You can remember this way. See now compare. AV is there, AV is here. Gamma is there. Earlier allowed stress was tau. Fyw by root 3. Now tau B is reduced stress. That is, you cannot stress the shear, you cannot apply shear stress of Fyw by root 3, it is lesser. See, finally answer comes to, later I will tell you. Okay. So, leave it. So, formula is VD equal to AV into not that formula, tau B. See, AV tau B is the nominal strength, divided by gamma MO is design strength. This is by simple post-critical method as per IS code 8.4.2.2a. This all told for you, everything explained for you. Okay, start. First, AV, shear area, same as last time, only web area, D into TW. You know D is 800, TW 10, 8000. See now, so your shear area is 8000. Okay. Now you require tau B. See now, to get tau B. Tau B is the shear stress. See, I am dictating everything. See, all the statements are from IS code. IS code. This also from IS code. These also from IS code. IS code. Tau B is shear stress corresponding to web buckling. That is, web is weaker. You should not stress it like earlier when it was not susceptible. You should apply lesser stress, or you can write tau B is the reduced stress or reduced strength. To get tau B, see what you have to do. See, to get tau B, procedure given. First, you have to find a term tau CRC, elastic critical shear stress. IS code has given tau CR, C. Tau CRC equal to KV pi square E, Young's modulus, pi square E by 12 into 1 minus mu square into dy TW square. This you get from IS code. KV you take 5.35. In the class I told the reason last time. Sorry. Those who are general public, you should refer. I cannot keep on telling other. It's not a course for you. It is for this batch. If you are knowing little, you can understand and benefit. Okay, KB over pi square, leave it. E, Young's modulus of steel, you know it. It is standard value where I wrote it 2 10 to the power 5. Where I had done. See, 2 10 to the power. We can write here. E for steel is taken as 2 10 to the power 5 MPa. Mu is Poisson's ratio. For steel, you can take 0.3. D by TW is already known to you. Substitute tau CR equal to tau CRC. Okay. Tau CRC equal to, where is tau CRC? See, 5.35 into pi square into 2 10 to the power 5 by 12, 1 minus 0.3 square into 80 square is 151.11 MPa is a stress unit. Okay, then once you get tau CRE, you find one term called lambda W. This is not your slenderness ratio lambda of KL by R. This is something else. This is called non-dimensional web slenderness ratio for shear buckling stress. But somewhat same as lambda only, slenderness ratio, but something special. The formula is square root of FYW by root 3 into tau CR. Is tau CR C or E? Tau CR E. C, I think. One minute. It is tau CR. It is, the print is not clear. Tau CR E. It is not C. Tau CR E. Okay. It is tau CR E only. Okay, symbol. Elastic. Okay, elastic. Where is it? Tau CR E. Okay. Tau CR E. So that is, substitute lambda W equal to this formula. Substitute 250 by root 3 by 151.11. This is no unit, non-dimensional web slenderness ratio 0.977. Okay. Once you get the value of C, this is your what? This is your lambda W. Be careful. This is your lambda W. Now, based on this value, IS code, I actually, when you solve a question, see, IS code told a case when lambda W is less than or equal to 0.8, one case, more than 0.8, less than or equal to 1.2, last case, more than 1.2. You should write applicable case right here. You need not waste time writing all three. Why I am writing? Because I am not solving three questions. I will explain here only. So, just to understand, right, as per IS code, if your lambda W is less than or equal to 0.8, your tau B, what you want tau B is FYW by root 3. That is, it's a very marginal case. Web is slightly susceptible. IS code told leave it. You take it as not susceptible. This all I told yesterday. I got angry also for you for not answering the question. Okay. Now, Suppose when you solve a question, if you get less than 0.8, you can substitute here over. Then if lambda w is more than 0.8 but less than or equal to 1.2, tau be equal to this formula right here. 1 minus 0.8 lambda w minus 0.8 close the bracket fy by root 3. Not root 2, root 3. I don't know why I put root 2 there. By mistake, I can make out it is root 3. Okay, this one. Or, that is our case right here. That is our present case. Present case. Why? Because see, your lambda w is 0.977. Anyway, to understand, make a note. If your lambda w comes more than 1.2, tau be equal to fyw, you already know it, by root 3 by lambda w square. Yes, somebody will tell, yes sir, whichever case comes we can do, because why? Everything I am covering. Okay, now last step for this question. See, now I will write here now, this all I will remove. I will remove this one now. Okay. Okay, this I still maintain. I will continue here. Therefore, see, therefore, for our example, not therefore, see, for our example, our present example, lambda w, we got how much? 0.977. 977 is less than 1.2 and more than 0.8. Therefore, we can write here, second case 2 applicable. Case 2 applicable. Case 2 is applicable. Therefore, your tau be equal to, see here, substitute. Once again write tau be equal to bracket 1 minus 0.8 times lambda w minus 0.8 close the bracket into fyw by root 3 over or equal to 1 minus 0.8 into lambda w. How much you got? 0.977 minus 0.8 close the bracket into 250 by root 3. Answer will come. I noted down the answer. Okay, check the one. No, not required. Where is it? 123.9. Yes, 123.9 MPa. 90 MPa. Anyway, I will check once again because this is going to YouTube. If it is personal class means, if it is a Zoom usual class, I will tell correct means you will correct it. Zoom I do not want, YouTube I do not want mistake. Calculate is not on. Into 0.8 minus 1 plus 1 into 250 divided by root 3. 123.90, correct. Okay. With this data, substituting. See here, this already over earlier. Design shear strength. Design shear strength of given cross section. Of given cross section. I remove this one now, not required. That is VD equal to how much? Once again formula, AB into tau B divided by gamma M. Root 3 is not there. Root 3 is already accounted there. Be careful. Equal to AB. Where is AB? I already told you AB 8000. Tau B, just now you got 123.90 by 1.1. This will come 8000 into 123.9 by 1.1. 901.09, not 9, 10 to the power 3 Newton. That is 901.09 kilonewton. Okay, over. Now remember, those who are in the course, Staad batch, now onwards, when you have to find design shear strength of a cross section, I will not talk anything. I will tell, go back, study and come back. Don't be lazy. You should be serious in the class. See, this is for my students, not others. I always give warning. Sometime I will tell, if you do not follow what I tell, you cannot learn anything. If you want to learn, you have to follow whatever I tell. Provided you believe me. I will ask, do you believe me? All will tell, yes sir, we surely believe. Okay, over. See, remember now, when web is susceptible to shear buckling, three cases are there. We got second case, first case, third case also clear for you. Okay, over. Now you can make a note if you want. Only those who want concept. Suppose this web is not susceptible to shear buckling, then its design shear strength will be, see, I will tell only for information. That is no tau v. Formula is what? AV, you write 8000 into Fy 250 by root 3 divided by 1.1. 1049, 1049, 1049.73 kilonewton. But no, this is not a correct answer. If web is not susceptible, suppose you reduce the depth of web and increase the thickness, maintain the same area, see 8000 area web, reduce the depth to 500, then thickness is 16, then 500 by 16 will give you 31.25, not susceptible. Then it is stronger case, same area, then can resist what force? 1049.73. But because it is susceptible, from 1049, strength reduced. That is reduced by what percentage? See here, 1049.73 minus 901.09 divided by 1049.73 is nearly 14.16% strength is reduced. Now, as if you make the web further deep and further thin, it will keep on becoming weaker and weaker. So the reduction of strength will be more. It will become more and more weaker. Just for those who want to concept. Okay. Now, everybody, I am sending this class now for you. General public, it is visible. Those who are general public, you can utilize it. See, if you know little bit, if you understand, good. But my purpose is, or my duty is to see that, see, this is class number 71. 70 class everything explained. 69 explained. So, my duty is to see that everybody who is in the group, it should be clear. It should be clear. Okay. Others, if you are benefited, I am happy. But along with them, you also understand. But I know how much they understand. Difficult for you unless you already know the subject. Okay. I will wind up now. Thank you.